Hey guys, today we're going to learn about comparing linear functions. There are four linear functions represented in four different ways right here. The first way is written in an equation form, then a graph, then a set of ordered pairs, and then a table. So we're going to name each function. They're already named, we just have to figure out what those names are. So my first function is going to be the rule. Now the rule is right here. I have f of x equals negative 4x plus 3. And I am going to name that rule because it's already named as f of x. It's given you the name right here. Now, the next one that I'm going to give you is the graph. The graph is right here. And it's got a couple of things on it that I want to point out. It's got two ordered pairs, so we know how to draw that line. And then it's got this letter G right here, and that is its name. That is function G. And in order to name that function, we're going to name it G of X. Everything will be of X. The next set of ordered pairs is our set, or the next function is our set of ordered pairs. Now, if you look at that ordered pair list, it is actually given to you as function h. So the h is what we're going to name it. It'll be h of x. And then our last function is a table, and that table is a set of ordered pairs all in itself. If you look at it, this is your x value, this is your y value. So that first ordered pair would be written like this, 0, 1. The second ordered pair would be 1, 6, so on and so forth. Now, if you have looked at this table already, you'll see that it's named J of x. So that table's name is J of x. So we have four functions, f, g, h, and j. So when you want to compare multiple functions, in order to obtain the information that you're going to need, you're going to want to represent those functions all in one representation. So I think it's going to be easiest for us to graph all four functions so that we can compare them. Our first graph that we're going to do is the rule, the f of x. Now, if I look at this f of x, remember y equals mx plus b formula, the slope-intercept form, where m is my slope and b is my y-intercept. Looking at this function, my m is negative 4 and my b is that positive 3. Now, the m, I can always make that function a fraction by putting it over 1. When you do negative 4 divided by 1, it's still going to be negative 4. The very first point that you want to plot is your B, your beginning point, your y-intercept. So that's on 3. I plot that point on 3, and then I'm going to use my rules from my slope. It says to go down 4 and over 1. 1, 2, 3, 4 over 1. Now, I want to make a really good line, so I'm going to do it all the way through my graph just to make sure that I've got it good. Since I'm going up, I'm going to reverse both arrows. Instead of down, I'm going up. Instead of left, I'm going to go right so it stays on that line. All right, you need to grab any straight edge that you have that you can find in order to draw a very good line. And today, I'm going to just use something that I have here quickly. And I'm going to draw that line. Oh, I accidentally went over 2. There. I was wondering why it wasn't going to fall on the line. Now, I'm going to have several lines on this one graph, so I want to name this line. This line is named f of x. Okay, the next one I'm going to do is the graph one, and I know we've already got it on the graph up here, but I need to put it on the graph at the bottom of the page so I can compare things. So that first order pair is 2, 4. So I'm going to plot that point 2, 4, and it's right here. The second ordered pair that it gave me was 0, -2. So I'm going to plot that point down here, 0, -2. And then I'm going to connect those 2 points. Once I connect those 2 points, then I'm going to label that line. I'm going to label it g of x, since that's its name. So the next one I'm going to do is a set of ordered pairs. Now, up here at the top of the page, the ordered pairs that it gave us was 0, -2, 2, 6, 4, 14. 4, 14 will not fit on our graph because our graph only goes up to 10. So I'm only going to be able to plot these first two. So 0, -2 is right here. We already have 1 point on that, but we can put another point there. That's fine. Over 2 up 6 is right here. So I'm going to connect those 2 points. Yes, I know this is going to get rather difficult to read. That's why I'm using so many different colors to help us out. So this one is h of x. And then the last one is the table. And the table is j of x. And j is 0, 1, 1, 6, 2, 11. Again, that falls off the graph, so I'm not going to be able to graph any more points. So 0, 1 would be plotted right there, 0, 1. And then 1, 6 over 1 up 6, plot that point there. When I connect those 2 points, I'm going to name that one j of x. So now you can see that there are 4 lines on our graph, and now we're going to be able to compare them a lot easier. So if we're looking at function name on the next page, we've already named all of our functions right here. So the last function that we just did was j of x. We did the set of ordered pairs, which was h of x. We did the graph, which was g of x. And then we did the rule, which was f of x. Now, I'm going to go ahead and draw a line because this first box has 2 questions in it. I'm just going to draw a line so I make sure that I address both questions. The first question says, identify the rate of change of each function. Now, if we're looking at function f, we've already identified our rate of change because our rate of change is just the slope. That's a fancy way of saying slope, and the slope is represented by an m. We already identified that our slope was -4, so I can write that down. The next one is the graph. Now, the graph, I'm going to use this graph up here because it's easier to see. And I can identify the slope this way if I go rise and then run. If I rise up 1, 2, 3, 4, 5, 6, and I run 2, 6 over 2 reduces down to 3. Making sure that this is a positive slope. It is going uphill, so that's how I know it's 3. H of x is, I'm going to create a table here. Remember, we have x and then y for the change in y over the change in x. I'm going to do 0, -2, and 2, 6. To get from -2 to 6, I am going to add 8. To get from 0 to 2, I'm going to add 2. So I know it's 8 over 2. 8 over 2 reduces down to 4. The last one that I'm going to do is my j of x. Again, I'm going to create a table using my 2 ordered pairs, 0, 1, 1, 6. To get from 1 to 6, I'm going to add 5. To go from 0 to 1, I'm going to add 1. So that means my change in y over my change in x is 5 over 1, which is 5. Now it says, which function has the least steep slope? So you're looking at numbers that are the smallest. And when we do this, I'm going to write that little note here. Look for the smallest number, ignoring the negatives. So we call that absolute value. But if you just look at the smallest number, ignoring the negatives, The smallest number, 4, 3, 4, 5, is 3. So the least steep slope is g of x. That means it's just not inclining as fast. The next question, it says identify the function that has the greatest y-intercept. Remember, the y-intercept is our b value. And our b value on function f we've already identified as 3. So on the g function, the graph, it's crossing the y-intercept at -2. Now, something that you need to look for when you're looking at the table or the set of ordered pairs is when the when the x value is 0, the y value is whatever that y-intercept is. So looking up here, my y value is -2 for h of x. And then on my table, my y value when x is 0 is 1. So the greatest y-intercept, 3, -2, -2, 1 is 3. So I'm going to just kind of put a bubble around it saying that that's what it is. Next, we're going to change all of this information into one equation instead of looking at my graph. By the way, I could have looked at my y-intercept right here, and it is the highest. So that's my pink line, and that was f of x. But instead of looking at my graph, I want it to look like the rule. So the first rule was given to us, and that was f of x is equal to -4x plus 3. The next rule, we're going to get that information by looking at our two things that we have found, our slope and our y-intercept. So looking at g of x, that's how we're going to start it off with. G of x is equal to our slope, which we found, m was 3. Then we put an x next to the slope all the time. And then our b was -2. Looking at h of x, our slope is 4. You, again, put the x next to it. And our y-intercept is -2. Lastly is our j of x. Our slope was 5. And then our y-intercept was a +1. So now we're going to identify the function that has the greatest value when x is 15. So all you're doing is plugging in 15 everywhere you see the x. So f of x is equal to -4 times that number 15 plus 3. I meant to write that in pink. I'm sorry. So I'm going to take 15 and plug it in here. -4, if you type that in Desmos, you can go straight to the answer. Just type in this right side of the equal sign. -4 times 15 is -60, and if I add 3 to that, that answer would be -57. Looking at g of x. So when I plug in my x value of 15, it replaces the x in all places. So 3 times 15 is 45 minus 2, so we get 43 for that value. Looking at h of x equals 4 times x minus 2. Again, we're plugging in 15. 4 times 15 is 60 minus 2 is 58. So h of 15 is equal to 58. And then j of x, so j of 15 5 times 15 is 75 plus 1 is 76. So j of x is equal to, or j of 15 is equal to 76. Then it says identify the function that has the least x-intercept. So we could look back over here to see which one has the smallest x-intercept. So if I look on this line, the least number that crosses furthest this way and the greatest number would pass further this direction. So the thing that passes the furthest on this side is my blue function. That blue function is j of x. So j of x has the least x-intercept. You could have also plugged in 0 and then solved the equation 0 for the j of x and solve the equation